This week, we talk hardware hacking with Ben Hibben, a.k.a. Blenster. In the security news, last year's open source is tomorrow's vulnerabilities. Repo jacking. I feel like there will always be authentication bypass. Supercharge your hacking. Do you have your multipath? RC4 and why not to use it? Here's the problem with vulnerability scanners. Packages and expired domains. initRD should not be trusted. Apple kernels. Oh, and did you hear? There's a new OpenSSL vulnerability.
No way.
Yeah, way. All that and more on this episode of Paul's Security Weekly.
This is Security Weekly. For security professionals, by security professionals. Broadcasting live from G-Unit Studios in Rhode Island, it's the show where exploits run wild, packets aren't the only things getting sniffed, and the cocktails flow steady. It's Paul's Security Weekly.
Right now, everybody is talking about cryptocurrency, and the cybercriminals are hiding in the conversation. Cybercriminals use social engineering loaded with urgency and fear to successfully prey on your company, your employees, and your customers. Spear phishing is just one of 13 types of email threats. Barracuda has identified these 13 types and shows you how you can protect your company, your customers, and your reputation. Find out about the 13 email threat types and Barracuda email protection. Get your free ebook at securityweekly.com/Barracuda. That's securityweekly.com/Barracuda.
And welcome to the show. But first, let me introduce you to a man who wrote all of his notes for the show in Drupal, Mr. Paul Asadorian.
Welcome, everyone, to Paul's Security Weekly. It's episode number 762, recorded here in G-Unit Studios in Rhode Island. To my left, Mr. Larry Pesce is here with us.
I am also written in Drupal.
You are... Why wouldn't you write everything in Drupal? Can you write in Drupal? How do you write Drupal? Mr. Josh Marpet is on the lines remotely. Josh, welcome.
Why, thank you.
Mandy Logan is here with us, although we can't see her. Only when she talks can we see her. It's a thing.
Hi,
feature. Hi, Mandy.
Hello, everybody. Hello, G-Unit.
Jeff Mann is here with us. Jeff, welcome.
Happy to be here, albeit remotely.
Yes, not in studio.
Here.
Yes. Sam Bound is here with us. Sam, welcome.
Good evening. I'm glad to be here.
Yes. All righty. You can now follow us and find us or follow us on Instagram.
Why not both?
Why not both? Follow us for highlight reels, giveaway announcements, and more at Sec Weekly. Except is it at? Does Instagram do the at thing?
Yep.
Like Twitter? Is it at?
Yep.
Yes.
Yeah, you can tell I don't
Yes.
use Instagram very much. But I will promise to use Instagram more than I do now, which is not very often, but I will promise to do that. So Ben Hibben, also known as Blenster, a chronic volunteer and hardware hacker, is here to discuss maker movements, hackerspaces, community and inclusive cultures, the right to repair, and using tools like the Arduino or Raspberry Pi to bring your projects to the next level. Ben, welcome to the show.
Thank you very much for having me.
It is nice to have you here. It's kind of a funny story how Ben ended up here. Like when I did a call with Ben, I was like, oh, wait, we've definitely met before, but I saw your Twitter post and you were like, so I don't have a job anymore. And all of like our collectively mutual friends were posting, and I was like, dude, you should totally come on the show. And like I looked into a little bit of what you did. I'm like, oh yeah, the guy that makes badges and does cool hardware hacking and teaches people how to use soldering irons and solder.
So for the record, Blenster's looking for a job.
There you go.
True story.
Let's solve that by the time the show's over. Go.
That's right. So Ben, it's wonderful to have you on the show. How'd you get your start in information security?
So there are two answers to that. The more public answer is I went to DerbyCon, which was local to me here in Louisville, and was like, oh, I can do this for actual money instead of risking crime. But the unofficial answer is I may or may not have been a precocious youth until I turned 18, and I may or may not have played around a little bit with stuff.
What do you mean?
Stuff. Nicely done stuff.
We referenced Bob. So what did Bob mess around with? when Bob was younger?
Bob may have been very curious about how the school network was put together and where the grades were stored and how secure that was and whether or not various servers on the internet were, what they were configured like, et cetera. Bob doesn't talk much about anything because he doesn't care if you believe him. And as far as he knows, nothing happened and you can't prove otherwise.
That's right. Bob's a character. Ben, how did you, but you didn't get started off in hardware hacking or even really hacking so much. I mean, it was hacking, but maybe not in the sense of cybersecurity, right? You kind of cut your teeth in a lot of different technologies, right?
Yeah, I've done so much crap over the years. I started getting paid to fix computers when I was 16. I ran network cables, terminated them, RJ45, DB25, etc. I did server and PC builds, installs. I did some sysadmin work, all the way back to Windows NT 3, whatever that was, way back then. I've fixed CD-ROMs when they were $600 and the CEO dropped it on the floor. And then I got into a program in high school. One of my friends came up and he said, "You're always fixing the computers. You're annoyingly good at art." I swear that's what he actually said. They got this art computer thing. You should go over there and talk to them about it. So I went over to the Voc Tech program, and my teacher, the guy who gave me the name, the Blenster, back in 1995, he was overbooked by 6 people and said, "I'm going to get you in anyway." So I went there and fell in love with making pretty things on the computer. Got a degree in that, and then ended up being the nerdiest designer. So that meant I had to write the code and fix the things, and that got me deeper and deeper into code. And then, building websites for clients like Jacuzzi and GoArmy. You end up having to deal with some of the blue team side because you need to make sure that your code isn't vulnerable. You do not want to be the person getting yelled at when a site like that gets hacked, because you're the one who committed that crap code. So that was the general journey. And after that, I came into a place called Level 1, which is a 501c3 educational nonprofit here in Louisville, Kentucky. Our mission is to help you make cool stuff. And in order to do that, we keep the space free and open to the public anytime a member is present. Try to keep the barrier of entry as low as possible. Membership is cheap and all that. And that's where I was introduced to Arduinos and Raspberry Pis, and took my knowledge of electronics from this is a capacitor, it does a thing, and this is a resistor, it slows down the current, I think, to now I cosplay as an EE. To be clear, I'm not an EE, but I'm getting better.
But it sounds like you've had hardware experience throughout your whole life, essentially.
Oh, yeah. Well,
wait. You got to realize something. He's being really, really calm about this.
He is.
But I worked at DerbyCon for its entire run, and Blenster would regularly bring in a fire-breathing Pegasus, toy cars that were souped up to beyond Larry level. Okay. And Larry has a pretty impressive level of toy car. Okay, let's be clear on this. The amazing amount of stuff that they would just throw together at Level 1 and bring in and cackle like kids when it would do something insane was amazing. Okay,
I will say I'm impressed by both. Larry has this and hopefully we learn of Ben's exploits in this arena, but Larry can lay claim to having one of his toy cars almost kill Bruce Potter.
Yep. And actually, it wasn't the.
I think that's a pretty unique claim.
And it was to clarify.
Was that
it wasn't
or after ShmooCon started?
It wasn't the car. It was the cannon mounted on the car.
It was the Shmoo launcher mounted to the car. Yes. So it was during ShmooCon. Yes.
Let's also be clear. Please, nobody try to beat that record. Okay.
Yes, please.
Yes.
Or Bruce.
Yep.
Bruce is going to kill us.
No,
Bruce,
that's already.
Sorry.
It went the other way. So,
yeah.
It's all good.
Sorry, Ben. We got derailed there for a
it's
moment.
all good. Yeah, I do have a story from the first DerbyCon, how I met Dave Kennedy.
Let's hear it.
Because I obviously didn't know anybody or anything at the time. Level 1 hosted an after party, and they were showing off the black badge that they made at the time, which was a laser cut, laser etched, edge lit acrylic, and it was pretty easy. And I was holding it, and Dave Kennedy was standing directly behind me, and I go, I could make one of these on our laser cutter in about 10 minutes. And Dave goes, please don't. I turn around and that's how I met him. And he was just please don't do that. And I said, all right, but one of these days I want to talk to you about this. And after a few years, they did actually come to myself and my buddy the Hat, and we were fortunate to be able to do the black badges for DerbyCon for 4 or 5 years.
Nice. So you did get to eventually do it with permission.
Yes.
Yes.
Yeah.
But
I'm still waiting
Ben,
for mine, by the way.
So Ben, you weren't in like cybersecurity until your first DerbyCon. Was that DerbyCon 1?
Yeah. That's when I realized that, hey, this can be an actual career, and not just something I do as part of my web developer.
Part of it, yeah.
I can learn all these things. So I started learning about capturing packets and network topography and all the crazy stuff people were showing off on stage. Just every security conference I go to where I'm not stuck in the hardware hacking village the entire time, and I use stuck in air quotes because I love being in there. But where I get to go see presentations, every single time I walk out of there a little more paranoid. Like, did you see the guy who hacked a MacBook through the power socket connector?
It's awesome. But now, when you came back to the, I'm assuming you went to the second DerbyCon?
Every one of them.
So when you came to the second one, like, did you bring stuff? Did you have projects? Like, what do you remember? What you kind of had
that's when the level 1 hardware village started up. We were there every year, and the first couple of years I was just a volunteer in that village, and we would show off the 3D printers, and I would teach soldering. And in fact, that's where I started teaching soldering at conferences, and it ended up being surprisingly popular. Turns out that my teaching style is a little bit different, and the way I explain the process is apparently a little bit better. So even people who've soldered before, who have taken classes, have found that my workshops are useful.
Wait,
so,
what's different? What's different in the way that you teach soldering?
From what I understand, because I haven't taken other people's classes, so this is just my third-hand relaying of their second-hand story of how they did it.
I get it.
Other instructors will say, we'll pull up the thing, they'll do a solder joint and say, do this. And then you just go about it. Whereas I will take the time to talk about the physics of what we're doing and why, and exactly what we're looking for and why, and what makes a good connection and why, and what makes a bad connection and why, and how to fix them. I will either, if I'm teaching 4 or 5 students, I'll wait for one of them to screw it up. If I'm only teaching one-on-one, I will screw it up on purpose, and then I will show them how to fix it, because that's a very useful skill, because not every connection is going to be perfect the first time.
What he's not mentioning, excuse me, I got to say this. What he's not mentioning is that he'll do this for a 6-year-old, and I've seen him do it. He will literally teach a 6-year-old soldering while explaining the physics at a level that they can understand.
Ooh, maybe I can learn.
Yeah, hold on, Ben.
6-year-old is right up my alley.
But explain the physics of soldering to a 6-year-old.
AKA Paul.
Yeah. It's about my level of skill with soldering.
So soldering is not like other forms of sticking things together. It's not like tape or glue, where a lot of pressure is your friend. If you use a lot of pressure, you're going to have a bad time. So instead, what we're going to do is we're going to use the tip of our soldering iron, and all of the bits up here are going to get nice and hot. We're going to use the heat that this generates to do work for us. What we're going to do is we're going to create kind of like a hot glue connection between a part and the printed circuit board that it needs to connect to. But this connection needs to be special. It's not just a mechanical connection, it's an electrical connection as well. So we need to worry about both the electrical and the mechanical properties of this connection. Now, you've seen water condensing on the side of a glass in the summer. You know, you got a glass of ice water or lemonade or something like that. You see the water on the side, and you see how it runs down, but it sometimes stays there in a little ball. It stays there because it's got surface tension. And while we're doing our work with the solder and to connect our parts to the pad, we're going to need to pay attention to the surface tension of the liquid, because when the solder has got the good surface tension, we're going to have a good time. And when it doesn't, we're going to have a bad time. How
So
far do you want me to
seriously,
it's really fascinating.
he really does it for kids. Like he explains it. He gets down to their level. He'll get. I've seen him get on his knees to show a kid how to. So he's at the same level with them on the table, and so he can show them how to solder or put the pieces together or explain how it works. I apologize if you haven't figured out that I'm a big fan of Blenster's. Now you know. The dude is amazing. Okay, he's a wonderful, wonderful person, and he teaches so well that I was sitting there going, I can understand this crap now. That's amazing.
Ben, what do you recommend people get started with, since we're on the topic of soldering? If people maybe haven't done much soldering, or like me, the soldering jobs I have done are really, really bad. They work usually, but they're really, really bad, and like we want to get better or learn. Like what should we do?
practice with a through-hole kit? I design kits that are specifically made for beginners.
Mm-hmm.
So at some point, I should probably go out and find other people's kits that are, I think, good for beginners. I have some friends who design kits, and I'm sure they're pretty good, especially the ones who've asked me, like, hey, how can I make this better? Because I have some thoughts. I've been teaching this for over a decade now. The reason I started making my own kits was I was, buying other kits on Amazon or whatever and just using them. And I remember the day we decided to do it, the Hat and I were leaving the Louisville Free Public Library, where we had run another workshop, taught, I don't know, it feels like 150 people. It was a long day, and there were 15 stations, and we were just running back and forth between these tables all day. And the kit that they were that they had purchased for us for this project was long and skinny like my pinky. It had one LED in the center. It had one battery on the back, and it had a post that you were supposed to solder on to pin it to your shirt. And that just flops all over the table. It doesn't sit steady. It's just miserable to do. The holes are too small to get the LEDs in cleanly. The pads were mislabeled. The positive and negative were backwards for some reason. And it was just done very, very cheaply and very much by someone who knew how to do soldering and didn't know how to teach soldering. So we were complaining that we could do better and decided we would do better, and we've iterated from there. But now all of our kits, they start, with at least 3 LEDs, because that forms a little table.
Mm-hmm.
So if I can get this at the right angle, you can see that there's an air gap. So when the student is leaving the iron on this PCB for too long, there's an air gap between it and the table. You don't melt the hotel's tablecloth.
Right.
Let me switch to this view. So you can see we've got these nice long pads here. Actually, you know what? Let's go up real close. I will see if I can find one. There we go. Let me get it on screen and in focus.
Focus is overrated.
So you can see we've got these nice long pads. They pull solder away from the center, and they make it much harder to do a bridge. There's 2 mistakes you can make. You can have too little, and you can have too much. Too much is the bigger mistake. Too little, easy to fix, you add more. So this makes it harder to put too much on there, and it gives you plenty of room to see how the solder is going to flow. It's nice big blob, so you see how it moves. And then, it's got plenty of room to get the iron in there. That's one of the tips that I'll teach is we use the edge of the iron, not the tip of the iron, because it's all about heat and heat transfer. More surface area equals better heat transfer. So the both the front and back are solid copper planes. One's a power plane, one's a ground plane. We do that so that there's a lot of copper to absorb the heat.
Mm-hmm.
And then there's a really, really thick trace. In fact, let's switch back to here. I will see if I can get it on the screen. Can't do my left or my right. Right, there we go. So you can see this really thick trace here.
Yeah.
That is electrically, you could run 120 AC through that. Like, there is no reason for that trace to be that thick for 3 LEDs. But the reason for that trace to be that size is that it has a lot of thermal mass, and it's harder to burn off the PCB by leaving the iron on there for too long, which is the whole point. Everything is designed to be is extremely beginner friendly. Everything's far apart. All of the holes are easy to insert. All of our silk screen is extremely clear. We've got plus and the minus, but we've also got a long and a short leg to show you which leg goes in which hole. Because again, these kits are designed for kids. The youngest I've taught is 4.5.
That's awesome.
Although I prefer to keep it to 6 and up. That was for a friend of mine.
Hey, Blenster, where can we find these kits?
Generally at a conference I'm at, because I'm terrible at business and don't sell them.
I'm gonna hit you. I'm gonna hit you so hard. Come on, man.
Yeah, I need to get our website updated and do all that. We just we had a rough Kickstarter failure, and I'm still trying to resolve that before I get anything else done, and it's just a long process of. Yeah, that's not a fun topic.
Moving along.
Yeah, I mean, things can go sideways when you're ordering lots of electronics, which kind of it brings me also to the supply chain. One of the things that we were talking about and have been talking about collectively for a long time, it seems like, is the shortage on things like Raspberry Pis. Right? We talked about soldering. Raspberry Pi is a nice way to kind of get into some hardware hacking that maybe doesn't necessarily require soldering, although it can, which makes it, I think, a really nice learning platform, coupled with the low cost for what you're getting in terms of CPU, memory, expandable storage, the whole thing is a nice package. However, what happened to the supply chain, Ben?
So, I want to be delicate here because I really like the Pi Foundation and what they do. I think they're a little bit of a victim of their own success in some ways. They made such a cool module that people started putting it in products.
Mm-hmm.
And then because they're putting it in products, they were making contracts with them to make sure that they got enough of them so they could make their products. And so it seems like most of the production is going to fulfill those contracts. Oof. And very little of it is making out to us. Normally, this would not be as big a deal because they could just spin up their production. But with the chip shortage, there is no spinning up the production. So they're kind of between a rock and a hard place. I feel for them. But it leaves the rest of us looking at, Pine 64s and other system on a board, trying to figure out if we can find something that's similar. But, the unfortunate thing is the Raspberry Pi is pretty singular in price and community and availability, or previously to this, and in terms of just being something that you could get in, you could the whole reason they built it, which is so awesome, is the idea that you could hand it to a child and they could break it, and the worst is you're out $25-$30, right? When they first launched it, they were talking about how classrooms would give students a laptop or an iPad, but they also gave them highly curated experiences because they don't want to break the laptop or the iPad because it's an expensive piece of capital equipment for them. They can't just go out and replace that easily. So everything is highly curated, and they're not encouraged to go experiment and play and have fun and break it. You give them a Raspberry Pi, and 9 times out of 10, the thing they're going to break just requires you to re-image the SD card. And there you go. And even if they break the hardware, building a robot or whatever, you slap another one in there and you get the robot going again. and that is fantastic. That is very dear to my heart. One of my big passions in life is advocating for the maker movement and getting and telling people that yes, you are a maker. You don't need to do it with an Arduino Raspberry Pi. You can do it with crochet needles or knitting needles or in the kitchen, or you can do it out in a garage, banging on your car. Like if you're making something, that is a way of empowering you to do something, to make something that yours, to and just seeing when I'm teaching someone at the Hackerspace or at one of the conferences, whatever, when I see that moment in their eyes when they're like, oh, I can do this thing, I can do all the things. I live for that.
That's awesome. The Pine 64 that you mentioned, speaking of alternatives, that doesn't come with a Wi-Fi adapter or chipset on board? It's an add-on, or you have to add a USB? Is that true?
I don't recall off the top of my head. I don't think I've used a Pine 64. I've looked at him a couple times going, maybe, but...
Yeah.
Yep.
Well, they're more expensive.
Pine 64, Beaglebone Black, Orange Pie, like there's so many different flavors.
Hike.
Yeah, exactly. So
Odroid has one now, too.
Yep. Everybody has one.
Yeah, I mean, you're basically talking. It's an ARM-based, integrated board, basically, with an SD card. But then, like, your mileage varies as to whether or not it's going to have Bluetooth, Wi-Fi, what other chipsets it might have, what other kind of connectors, headers on it, right, for connecting to other things.
Yeah.
And going back to Blenster, like if I can, because I was thinking when I learned soldering or learned of it, the first time I remember was probably 4 years old. And then by 7 doing it, but my dad came from construction background. And so it became that I had to do it after I destroyed my remote control fire trucks and stuff, like after pulling apart all the wiring, pulling apart the motherboard and stuff. Then it was like, well, you have to fix it. So here, do this. So it wasn't really like any complex circuitry. It wasn't anything that I took as being like hardware or computer related. And yet I was wondering, like when you're working with kids, do you bring up things like that or show them that they can actively do things to fix or to help spark that idea?
So one of the volunteer activities I did for a couple of years before the pandemic, and we'll probably start doing again at some point, I ran a free repair cafe at the Hackerspace called Fix It Friday. And people would bring me whatever and we would fix it. And one of my favorites was when people brought their kids and we could fix it together. And so that's...
Oh, you don't try to fix the kids, do you?
I do have to say, Ben, though, when it comes to fixing it, sometimes that requires desoldering. In that, I mean, the same physics, right? But like, what do you recommend for there you go, for desoldering, which is I'm like, oh, I can fix that. Like, I could probably solder that. But when I get to the desoldering, I'm like, I'm probably gonna melt this in the process because I really suck at the desoldering part.
I mean, that's kind of the point. You do need to melt it.
Yes,
but only just a little bit. Just the tip.
And that's a desoldering wick, right? Is that what you call that?
I do have some desoldering braid somewhere.
That's a solder sucker.
Solder sucker. Sorry, the technical term for that is
solder.
solder.
On my desk currently.
Is the technical term solder sucker? Is that what they call it?
Yes, it is.
That's what it's called.
Yep,
solder sucker.
You push the plunger down, you let the button go, and it literally creates a vacuum through the little tip. And the tip is some rather heat-resistant plastic.
Gotcha.
The silicon.
Yep.
Silicon tubing.
Yep.
I feel like I always get my timing wrong when I do it. I guess it's just practice like anything else, right?
Yeah. It's definitely a practice thing. I have done a lot of it. You can also use hot plates. I have a small one right over here.
Is a hot plate easier than the solder sucker?
It depends on what you're doing. So this is good for through-hole components.
Yep.
But if I was going to depopulate components off of this little board, then I would want to use. It's right here. It's on my desk in front of me. I got this cute little hot plate.
Oh my God, that's tiny.
Yeah, right? It's adorable. So I can plug this in, turn it on, put this on here, and then use my tweezers to pull components off one at a time.
That's awesome.
And I've had to do that. So, full disclosure, I've screwed up a board or two in my layouts. One of them I did for work. I got the inputs wrong on one of the ICs, and I needed to swap 2 pairs of data lines, and so I had to, and there, chip shortage, so I can't just order new parts. So I end up taking the old boards, putting them on top of that, pulling everything off, sending it down here on my silicon mat, then putting the new board on there and putting them back on the new board in the right spot, and then everything worked.
Nice.
So let me throw something at you, because there's a couple of different goals for having you on the show, and one is obviously to talk about Hackerspaces, and Level 1 is an awesome hackerspace. By the way, I've been there; it's amazing. I cannot recommend it enough. It's so nice. The people there are just lovely. So we could talk about that for hours, not a joke. But just for a minute, I'd like to talk about you. You are looking for work. What kind of work are you looking for? I'm honestly curious what you do for not for fun.
So this is a hard problem for me, because I have done almost anything you can do for money on a computer, with a couple of exceptions.
No cam girling?
Yeah, none of that.
What's your OnlyFans?
Yeah.
I've not done that, and I've not done anything illegal for money, because I have ethics.
I can just imagine you teaching a soldering class on OnlyFans.
I'd watch.
All right, everybody, let me show you my solder sucker.
So
I'm sorry.
Not everything on OnlyFans is adult natured.
Correct.
People do like to watch me solder, and I have the setup here if you guys want to see me do some surface mount stuff.
Oh my God, I so do, because who was it? BSD Bandit was like, if you want to see someone solder, dude, you got to watch Blenster. I'm like, he's coming on the show next week, and now you just offered to solder live on the air. I'm totally down. But continue with your story first.
Yeah. So as what I do, I'm looking for an interesting team and an interesting project. I can do almost anything. I'm a deep generalist. I know more about more, and I know more about more than a lot of people think. They hear jack of all trades, master of none, but some of us are a jack of many trades and have mastered several of them. I have done all kinds of stuff. I'm not a DBA, but I have designed relational databases with a client, and then built them, and then wrote the stored procedures, and then wrote the data layer and the back end, and then wrote the front end after doing all the design work to match all the print design work, and shot and edited videos to match all that, and then done print mailings for all of that. My degree is in graphic design and interactive media. I did, when I did websites for a couple decades, and near the end of that, I specialized in data-driven interactive content. So stuff coming from a database through XML or JSON or some other format, and going through some sort of UI, usually Flash or HTML5, and populating dynamically. So that's
software
stuff,
quality assurance.
Yeah, got really burned out on that.
SWQA automation. Talk to us.
Yeah, and I switched over to engineering. I got a job as an integrated systems engineer at a startup. They were doing an automation adaptation for legacy equipment, paper cutters, and their hardware had to be adapted to each machine. Every machine from the same factory, even within a couple months of each other, the pins would be different. They populated the boards differently. They had some sort of process where they were constantly changing their hardware. So every single machine had to be pinned out and then integrated manually. And I'm the person that, figured out how to do that, how to document that, and how to train other people to do that. And then from there, I got a job at GE Appliances as a software QA automation engineer, which I'd never done before. But my friend of mine worked there, and he was like, "You're smart. You know microcontrollers. You know programming. You can learn a new language. We're going to train you on the job." So I started off there with no experience whatsoever in that, and by the time I left, I was a senior software QA automation engineer responsible for architecting and building our core tools that other automation engineers would then add on to, teaching the new folks and helping manage our overseas assets. So based on that strength, I was recruited by June, which makes a really cool smart oven. It does onboard computer vision, so it doesn't go over the cloud. So you don't necessarily need a web access to get it to work. You put in cookie dough and you just put it in there, and it's like, hey, are these cookies? You want me to bake them for you? Yes, please. And it does it for you. So
That's
I was working there for a while, and then they got bought by Weber, and Weber went public, and they're not doing so great in their stock, and they laid a whole bunch of people off, including myself.
And now you're now you're here.
Now I'm here. Yeah, so I've been talking to a variety of companies. I've interviewed for a CTO role at a small spin-off company. I've talked to a company about doing two companies actually about doing hacking educational material, because I have a good background in teaching and putting together educational content, interactive content. And while I haven't done a whole lot of active pen testing, I have done some here and there. Some of the startups I've worked at. How much can I say without bumping into the NDA?
I heard that pause there. The gears were turning. Like, wait, should I say what I'm about to say? You don't have.
Yeah, I've done security work, but almost all of it has been under very strict NDAs, where they're like, we do not want you to tell anyone about any part of this.
Yeah, no worries, dude.
Which makes it miserable to say, hey, I've done this before, but they had 18 different firewall rules with all access, all ports.
Yeah.
They had no logging on.
But you also did some tell us about the badge work. How do you set out to go design a badge for? Did you design badges for conferences? Is that one of the things you've done? How do you set out to do that?
That came out of one of those workshops at DerbyCon. So I was teaching soldering at DerbyCon. This is before we had our own kits, and we were selling a kit from somebody. Might have been Adafruit, but it's a persistence of vision kit. It was pretty cool, but it's very tightly packed in there on this PCB, so it's not a very good beginner's kit. And a woman came in, and she was very upfront. She's like, I've had it up to here with dudes mansplaining to me all friggin' day. I might want your help, but I don't want you to just assume I don't know anything. I was like, yes, ma'am, I understand. I tell you what, I've been wanting an excuse to build one of these. You buy one, I buy one. We'll sit down together. We'll build ours together. We'll have a nice conversation. We'll make sure that they both work. And so that's what we did. And hers worked and mine worked. And she went off feeling much better about her day. And I went to the dance later that night, and I'm spinning my little thing around. I haven't had a chance to program it, so it's still got the default animation on there. And I'm looking around at the crowd, and I'm like, I think I might have the brightest LEDs. Why did none of my students bring one of these? Because I sold like 10 of them. We've made a bunch of these. Why am I the only one with this? And then I'm like, well, at least I have the brightest. And then I see this guy with this hat. And the hat is strobing. And so it's a very short pulse, but it's possible that the peak luminance is higher than mine, but I'm definitely beating him on RMS. So now I'm having this nerdy conversation with myself. What's brightest? Am I being unfair to this guy? How do you judge this?
I'm dying.
Now, Paul, you did ask the question.
I did. I'm dying.
I decide that next year I'm going to this dance, and it's not going to be a question as to who's brightest. It's going to be known. And I tell my friend Charles the Hat this, and he said second brightest, and we engaged in a merry little back and forth war for about 6 months, and then we decided to collaborate, and we built what's now known as the Mega Bling, which is unfortunately mine is not working right now, or I would turn it on and blow out.
We know who's smartest.
I want to see it. I know.
I can show you pictures at some point, but yeah, we had the brightest things not mounted to the stage. It was absurd. You could find either one of us in the crowd by looking for the bright glowy spot. One of the two was one of us. And
was it like a full suit? First... Like, are you? This is like Iron Man, or like?
Yeah, it was big. It was yay big, and a triangle, and it had 1/4 amp per channel RGB LEDs.
Good Lord!
Holy God!
Good Lord!
Yes, It ran on 650s for about 2 hours. It was
that powers my home drill for like 3 months.
Yeah, we had to use an automotive grade buck converter for the power dissipation. It was just it's a monster of a thing. It was also really heavy to wear and didn't run long and all that. But that was the first wearable we did. We also did some smaller versions of that with APA 102s, also known as dot stars, for the level 1 hackerspace, and then people were like, shut up and take my money. So we started with that. DerbyCon reached out. They had a problem with their black badge supplier of some kind. They couldn't get them delivered for whatever reason, and they said, "Can you design something for us?" So that we made the I guess slightly infamous signpost black badge, because it was a little big and a little pointy, and if you sat down, it might hit a gentleman in a sensitive spot.
Ouch.
But it lit up in 3 different spots, and it was matched to that logo for that year. And their jaws dropped and were like, wait till you see what we have for this year's badge, because that one we kind of did in a hurry. That was the recharge badge, which you can find on my YouTube channel. You can also Blenster. There's 2 videos of it there. There's one showing the different modes, and there's another one showing me doing assembly by hand with fine tip iron and tweezers, because people didn't believe that I was doing it by hand for whatever reason. So I did a time lapse. So that blew their minds away. And after we did that, other conferences were like, "Hey, that was really, really cool. Can you do that for us too?" And we started losing less money on our electronics hobby.
And the answer was, of course, no, we can't do that for you, but we can do something better or similar or different.
Yeah. Well, most conferences were not willing to spend as much. DerbyCon was willing to put in some money on their black badges. We did not make money on them. They were still very expensive. Other conferences were like, yeah, we got a $50 a piece budget, so we're gonna laser cut some stuff for you and backlight it.
Yeah.
And we'll build in some animations and stuff, but like the recharge badge, I think the LEDs cost $50 in the bag. There's 170 some odd of them, and in different colors.
Yes, it was bigger than Flava Flav's favorite clock. Okay, seriously, man, those badges were the size of like small automotive lighting systems. I mean, and they lit up like there was one, I forget which one. Was it the recharge badge where it lit up in like waves of LEDs, and it actually had a sound, a spectrograph in it, and oh my god, it was ridiculous.
Yeah, recharge had multiple animations. It had a couple different. It would go back and forth with the Larson scanner. It would light up one at a time. It would do random speckles. It would. I'd have to check the video. My favorite one that we did for DerbyCon was the Legacy badge, and I still haven't made our version yet. The Hat and I each get one. I've got the hardware sitting around. I've got the boards mostly populated, but it's 9 microcontrollers and 198 LEDs.
Wow.
And it's just a lot of work to put that together. And then that has to be the light guides have to be glued together into the wooden frame, and then it all has to be shellacked. But when it's done, it's just beautiful because it's a wooden badge. It looks like it's solid wood, and then it lights up like it's burning from inside. It's money.
And the microcontrollers you were talking about, what is the MS4? What is I forget the model number now. You gave me some model of the stuff you can buy now. It's like $12.
MSP430s?
MSP430, thank you. That's pretty common on badges and a lot of electronics, right?
We used all Atmel stuff, Atmegas. That's what the Hat and I are familiar with because we got into it with Arduino.
Yep.
Now he's an actual software engineer, so he does pure embedded C. I am doing hybrid embedded C. I still lean on Arduino a little bit here and there, but I've transitioned over to VS Code with Platform IO and not using the Arduino IDE as much anymore.
And so when you're coding for an Arduino, is it their language or can you code in really any language?
C, C++, and the Arduino isn't the language so much as it's a wrapper. It's a
framework. You were to explain this to me, yeah.
Yeah, so this is a microcontroller, and it doesn't talk to the world in the way computers talk to the world, or at least the way we talk to computers when they're talking to the world. So in Python, you can, on Raspberry Pi, you can just say, set this pin to high, and it does that for you, and you don't have to worry about it. If you're writing straight for a microcontroller without Arduino, you are not writing to a pin. There are no individual pins. There are pin registers, and there are 4 or 8 of the pins grouped together in a register. And every time you change the status of one, you have to write all of them. So you have to keep track of what the status is on all of them, and then maintain that correctly. What the Arduino wrapper code does is it hides that from you. So instead of having to worry about a pin register, or even knowing what a pin register is and how the hardware works at that level, you can just tell someone like a 12-year-old, like, just write digital write pin number 6 to high, close parenthesis marks, don't forget that semicolon. and there you go. It writes that pin to high, and it masks all that for you. If you get to the point where you're getting performance bottlenecks, that's when you need to start stepping away from Arduino, and instead of using Arduino functions, start writing straight to the registers yourself.
Right. I got into this with UEFI uses registers in a similar manner, right? You change the register values. Basically, you change the register value, and it tells the hardware to do something physically with the hardware.
Yeah. So on the hardware, there will be a bunch of logic gates, and that's those gates are being operated. That's the physical register you're talking to, and that's why you have to talk to the whole register, because you're talking to a chunk of hardware directly.
But when you're starting out, better to use Arduino, which you can write code in different languages to interface with Arduino, which takes care of that hardware layer for you.
So this is an Arduino Nano. This has got this is basically pin compatible with the Arduino Uno, but it's a little bit smaller. I've got an Uno right over here, thanks to SparkFun. One of their excellent kits. Not a sponsor. But this is one of the projects I use when I'm teaching. It's a simple Larson scanner, but this is the Arduino Uno on this side. And you can see it's got and you probably can't read on the camera, and even if I zoomed in, I'm sure the video compression would ruin it. But there are a bunch of notes here showing the pin numbers. Some of them have special little squiggles next to them that show that they're a pulse width modulation capable pin. Some of them are analog. Some of them are for the serial transport. But you can use this is just a really easy way to get into talking to the world through hardware, because you can write the digital writes. You can do a digital or an analog read really easily. And you can make a light turn on and off. That's kind of like the hello world is blinking an LED and then getting it to change speeds and all that. So this one does all that, and the code for it's up on my GitHub. It's the Arduino example I have up there. And this is the one that I teach when I'm doing a hardware hacking village that's not as busy. Because if it's busy, I'm standing there teaching soldering from when we open the village till they kick us out, and then I finally go eat. Although occasionally some people will bring me lunch or caffeine,
or both.
So
They're both. Yeah.
these two things are basically the same thing, but this is a different. This and this are the same microcontroller, but in different packages. So this is what you might prototype it in, and then when you're building a product, you might put this in, or a project if you're going to embed it in something. This right here is an SB32. It's related to this SB8266. This is a really interesting story. Basically, this was designed to be a Wi-Fi module that you could talk to via serial AT commands, just like any other modem. Turns out that it had 2 cores and some inputs and outputs on there, and so some clever hacker figured out how to get it to do other stuff. And instead of being mad at them, Espressif went all in on that, and that this became a really cheap alternative because the Arduino that I've got here is, $15-20 if you buy it online. You can get an SB32 here with 4 cores, Wi-Fi, Bluetooth, and a whole bunch of GPIO, and the ability to write for it in the Arduino IDE or other similar beginner-friendly interfaces. And you can get these for $3 or $4, and they're already FCC certified, so you don't have to worry about all that. And so now you're seeing them show up in products all over the place.
Last I bought some of that style of stuff was some ESP8266s, and I bought them in bulk. They were the Node MCUs. They were some generic knockoff Node MCUs from like AliExpress or wherever. And I think I bought 40 of them. And when you bought 40 of them, the price came down to about $1.25. So, yeah, it gets super cheap, and then you start seeing that stuff show up in everything.
I mean, other than blinking in LED, if people want to do stuff with them, what's some good starter projects beyond making flashy lights?
So one of the cool ones I like to tell people about is, flat screen TVs are pretty cheap these days. So a cool project that you might want, be inspired to build is to put a motorized TV mount in the foot of your bed so that your TV can rise up, and then you can Netflix and chill, and then when you're done it can go away and be out of the way. But in order to do that, when I was a kid, you needed to know an electrical engineer and have a whole bunch of money. These days you need some limit switches, an Arduino, a button, and some motors and other stuff. There's way you can find a motor kit to lift it up and down. You can build your own cabinet for it, all that fun stuff. But say like me, you have a cat, and so you can't just have a button, or maybe you have kids and you don't want to have a button that makes it too easy for the screen to go up and down. Say you want to have it respond to the secret knock. Well, you can Google for that. There's a gentleman put together a really cool project for one of the maker fairs with a not a vending machine, one of those gumball machines. He made it completely out of acrylic so you could see how it worked. And instead of just pressing a button, which he thought was boring, he wanted kids to do the secret knock. So he's published his code on how to do that. So there's code for listening to the secret knock, including at different speeds, that you can just borrow from the community, and then you could, glue a piezoelectric disc to the wood, and then you can make it work.
Awesome.
All sorts of cool stuff like that. Again, like I said earlier, when I get someone into this and they make their first thing with the Arduino and they see it respond to a switch and turn a motor or whatever, and they start to realize just how much they can now talk to and listen to the world around them, and how many of their own unique individual problems in their situation that they can now solve on their own. That I love it. I just absolutely live for seeing that.
And of course, the joke being that they probably could have solved every single one of them with a 555 timer.
Oh yeah. Well, I mean,
sorry, I had to.
If you're a bigger nerd than me.
Yeah, exactly. So, Paul, you talk about a beginner project that isn't necessarily a blinky light. Well, I made arguably a beginner project that is a blinky light. It's just bigger. I know we've probably seen it on the show, but behind me in my office, there's a set of traffic lights and actual full-size traffic lights that came off of a pole somewhere. And I replaced the lenses.
Bob got them.
I got them at a yard sale, just type of thing. And I don't know where they got them from, and I don't care. But repainted, made them nice. But use an ESP8266, loading the web modules so that it can create a web page. So you can press buttons on the web page, and it toggles those pins. And in my case, those pins happen to toggle a relay so that it will turn 110 volts on and off to turn the light bulbs on and off. But because it also has a button, it also has a direct URL which you can access those buttons with something like curl. So I have some curl commands on my Stream Deck so that I can turn them on and off with a button on my Stream Deck.
It's awesome. Possibilities are endless. Were you going to do some soldering for us, Ben?
Oh yeah, absolutely. Let me turn on the iron.
Get the iron warmed up. Does anyone else have questions for Ben? Cool projects that they've done. Now you've got a list of projects in your head. You're like, now you've motivated everyone and inspired everyone, Ben, to go work on this stuff.
I have more of a comment. I don't think I've ever seen Blenster without his octopus hat on. So like, who is this guy?
True. That's true.
Well, I figure if I was going to do a soldering demo, it might get in the way.
And your beard doesn't?
Sometimes
The beard stays behind the table because it's long enough to go up against the table.
Okay.
When it was shorter, it would get in the way.
Now, I was going to say either the octopus hat or was it for a while the Android logo hat?
Yes, I had the Android beanie for a long time. That was one of the ways I would tell people how to find me. Look for the Android beanie.
And it
All right, so we'll start off with something fairly large. I can get that centered. Do I have a big enough?
I should have said this before the segment. If you're not watching the video version of this, you should
Go find
Yeah.
it.
Yes,
It's on our
and
YouTube-
not while you're driving.
Nope. It'll be on our YouTube channel. Not while you're driving.
So what I'm going to do here is I'm going to get some resistors out of a strip of paper that they come stored in. And this is going to be a little bit different than through-hole soldering. But we're going to do a couple different sizes just for grins. What I'm doing right now is I'm applying a little bit of flux to the pads, and that is because the solder that I'm going to use is really thin. This is how thin it is.
Yeah.
And it does not have flux core in it.
Mhm.
And as a result, it's not capable of having the advantages of the flux or the rosin. What the flux does is it changes that surface tension I mentioned before,
Mm-hmm.
and it's going to give us more advantageous surface tension properties. It's also going to be an astringent that cleans these pads. So I'm going to just put a little bit of solder on two of these pads to get them started. And then we're just going to slide a resistor over here. And at this scale, the surface tension can be problematic because sometimes it'll lift it up into a stovepipe configuration, sometimes called tombstoning. And we don't want it to be
Tombstoning, did you say?
Yep, meaning it is close to standing up on end, so you cannot read the 103 and it right up,
Okay.
or close to.
See, I still did more soldering on copper pipes than on boards. So I'm more used to that way. Sweating copper pipes, like for plumbing.
Those are small, but they're fairly large compared to some of the other stuff we can do. So let's look at another size down.
You made it look effortless, by the
Yep.
way.
Ben, what are those 0406?
I think those are 0603s.
Okay.
Or maybe 0804s. These are going to be 0603s, I think.
And if I remember correctly, Ben, the 0603 refers to the number of millimeters of the size of the component.
Yes.
So 3 millimeters by 6 millimeters to give you an idea of scale.
Well, 0603 means 0.6 by 0.3.
Got it.
So let's put a couple of these capacitors down for scale. So these are going to be a little bit smaller. We can see they're just all right. They're a lot smaller.
It looks a lot. I was going to say it looks a lot smaller.
By about 1/4, roughly.
So we're going to slide over here. You can see I've done some resistors already. There we go. That's what I want. Sorry, this camera's left and right, up and down are funky for me. So once again, I'm going to apply a little bit just to clean those pads up. That's actually a little too much, but it'll boil off. So this is different than the through-hole soldering. Here we're getting into where it gets real picky about how you handle it. This is definitely a more advanced
It was
level.
like just the right amount of solder too.
Mhm.
Yeah, there's very much a Goldilocks amount for each of these operations, and knowing that Goldilocks amount is critical.
And just practice, really, right?
Yeah, then this is especially fun when you're not, like actually looking down on it. You're doing it across the table and under a camera about a foot away from you.
Yeah, which makes it challenging because certainly you don't have the same the ability to judge depth.
Mm.
Yep, and I see. While doing that one, I overheated this one, and now it's stovepiped and sticking up. So I'm going to see if I can't talk it into behaving for me.
Mhm.
Could you pretty please line up? Don't embarrass me in front of my friends.
I love it. Well, general recommendation on temperature of your soldering iron, which I think is something that when you first start, like you don't
Make it hotter.
Yeah, you don't know. Like either it's not hot enough, like getting the right temperature that's a thing, right?
Yes, absolutely. So I run mine at 750. I'm just very comfortable with that. All right, I thought I dropped 2, but I'm only seeing 1.
And now we get smaller.
Where is that other one? I will find it later, I'm sure.
With the vacuum.
With my foot.
Yeah. You might actually not find it all that well with your foot.
Yeah, these are even itty bittier. So there's a couple of. So we've gone from over here down to here, and now we're going to go all the way down to here. So those are going to go. Let's see here. We'll go down here. We got some 0603s, or no, these are 0402s. I'm sorry. And here you see it gets annoying. It'll stick to the tweezers now because they're so light that even just the smallest amount of surface tension will hold them on. So for that reason, I will occasionally stick my tweezers in the wet sponge and try to clean it off. Let's see here. Yeah, this pair right here. That seems to be on screen. Try to do this where you can see. Yeah, for whatever reason, people like to watch me do this. So sometimes when I have a time and a project, I'll stream on YouTube or Twitch and build something.
It is amazing to watch. It's very soothing.
Cathartic.
Yeah.
Very calming and therapeutic.
Yep.
I like it because there's a sense of accomplishment with it, and it's very precise. You got to think about what you're doing. See, that one's not very straight, so it's not going to hit that pad properly. So we need to heat it back up and maybe convince it to be a little straighter.
It's kind of like you got some influence, but not control over it.
Yes. And at this size, you can actually heat all the way through the part if you're not careful. So I got those lined up, and then they'll stick to your iron. So at this point, like when I teach the through-hole class, I teach about the Goldilocks amount of tinning you keep on the iron. On this one, you want to keep it dry, and you want to add the solder very carefully, and you have to very carefully modulate the heat. You don't get to just sit here with the heat touching the part in the pad and just sit there for a long time. You need to get in, do your work, and get out before it gets too hot.
I got you. Yeah, because the parts are so small, just the heat transfer will melt it.
Yeah. What will happen is the solder loves the heat, so it's going to go where the heat is, and if you give it the opportunity, it's going to take that part with it, and because again, the surface tension is not in your favor at this scale.
Yeah, Ben, on that first one you did, we could literally see that you hit that second end that you were soldering there, and you could see it heat all the way through and start to drag away,
right?
Because it had unsoldered the other end.
Yep. So that's where you have to be really, really careful with those. And I can do more. I've got a whole bunch here, but I don't want to bore you all.
No, it was amazing.
You're
It was-
not boring
no,
us,
yeah,
dude.
that's-
Seriously.
Having that as
I find it really, really fun. And one of the things I've learned about being a nerd is that sometimes the things that I find are really, really fun, other people are just being polite about.
Yeah. No, we're all digging it for sure. For sure. Ben, it's amazing stuff. When you're starting out, probably not soldering components that are that small. Work your way up to that.
No.
Yeah, I kind of want to see a size comparison of those components with like a strand of hair.
I will show you.
Pull one
I
right
can
out of
do
your
a couple
beard,
of
Ben.
size
Yeah.
comparisons.
Sacrifice a beard hair.
Just lay the beard
Oh
down.
no! Don't do that.
So here
I'm not
is
serious on that.
here's a standard 5mm LED.
Wow.
That's
Yeah.
the sort of thing that we put in our kits, like I showed you before. That had the 3 LEDs in it. This is one of those LEDs. You can see the parts, and right here next to it is one of the surface mount LEDs.
Wow. That's crazy.
Yeah, 0603, I think. So you can see it's much, much smaller. Same with the resistors. It's right here. You mentioned a 555 timer.
Mm-hmm.
This is a 555 timer.
Yay!
And it outputs a clock signal, which goes over to this digital counter. This digital counter has 10 outputs that it cycles through, and that's what lights up these LEDs. So there are 10 LEDs in a circle around here, each one with its own current limiting resistor, because each LED needs to have a special resistor to kind of keep it from consuming too much power. If it consumes too much power, it'll
Let the magic
burn out
smoke
quicker.
Let the magic smoke out.
Magic smoke.
Yep. So these are for protection. So you can see it's connected via this trace right on over to here, and so these will go around in a circle. Let me switch to this view. It'll just go around in a circle. But there's one LED here in the center that will flash with each clock output from the 555 timer here. And there are 4 LEDs on the corners that are blue that are driven through transistors, which I've not yet populated on this particular project. And those transistors are they're like a automatic switch. They're at the core of everything that we know and love as hackers and nerds. They're the ons and the offs. They are the things that do the zeros and the ones on the hardware.
Mm.
And in this case, they're turning on and off power directly from the 5-volt source through these blue LEDs, because they require so much current that if you tried to run them through these ICs, you might damage the ICs. So that's one of the reasons why you might choose to do something like that through a transistor. This kit also has some micros on here. They're not connected to anything, but they're just a chance for me to show off. Show how to do the various packages, the pins. Unfortunately, I've already done these, so I can't show off again. But it's quite fun to bang those out.
It's awesome. Amazing stuff, Ben. I just have 5 questions left for you. Are you ready to play 5 questions with Security Weekly?
Oh man, I saw you do that, and I said I should write these down so I have a decent answer for them
No,
next week.
off the cuff is
No,
better.
no.
All right, Ben, you ready? 3 words to describe yourself.
Capable, kind, and intentional.
If you were a serial killer, what would be your weapon of choice?
Wouldn't you like to know?
I don't think
Best
anyone-
answer
I think that's one of the best
That's
answers
the
we've
best
ever
answer.
had.
Best answer. If you wrote a book about yourself, what would the title be?
That's a really good one. See, that would depend on which part of my life. Like, if about my childhood, it would be about survival. If it were about my early career would be about web development and best practices and accessibility and all that, and now it would be about the maker movement. I think it would be a incoherent book. So
That's a great title, an incoherent book.
there you go. There's the title.
What's your favorite hacker movie?
Oh, there are some good ones. I'm gonna go with The Matrix, the second one where Trinity uses Nmap to finger a Unix server and drop an exploit on it.
Choose 2 celebrities to be your parents.
Alive, dead, fictional, or otherwise.
Ooh, an upgrade. The short version of that comment is I had a very difficult childhood. I was taken in as a ward of the state and put under protective custody at 16.
So, upgrade.
So this is definitely an upgrade. I would want kind and empathetic and curious parents with the means to be able to foster that. So
Submit
Kanye
your
and
applications today.
who's famous that fits those that category? Because I'm bad at famous people.
Angelina
bet it
Jolie.
Made me
Names and
think
Angelina
of Super
Jolie.
Nanny. I don't know if that helps you. It made me think of Super Nanny.
There you go. I need that and
Glinda.
Iron Man. I don't know. That would be fun.
All right.
Yeah, that
Nice
works.
job.
Yeah.
Fantastic. Ben, thank you so much for appearing on Paul Security Weekly.